Hello everyone. The topic which we are going to cover in this video lecture is digital protection. It will include subtopics like what is digital protection, what is digital protective relay, components of digital protective relay including block diagram and its operation. Starting with what is digital protection. In a large interconnected power system having large size of alternators, transformers, transmission line, the protective relays and circuit breaker, basically the protective devices or switchgear devices, need to operate in minimum time period of operation so as to improve the transient stability of the system. We all know that whenever a fault occurs in our system, power system, it introduces for a transient into the system. Now, what are these transient? Transient consists of large number of harmonic current and voltage with addition to the DC component, and we need to extract the fundamental component from this transient. For this purpose, earlier analog filters were used to extract the fundamental component. But with the advancement in the technology and the advantages a digital protection relay scheme offers, analog protection schemes are overcome by the digital protection. Here are some of the advantages a digital protection relay scheme offers over the analog protection scheme. The first one, the mini computers, microprocessor and microcontrollers used in the digital protection offers low burden and low maintenance, plus they are not affected by the mechanical shocks and vibration, whereas the analog ones get easily affected by the external causes. So here the digital protection devices offers offer an advantage over the analog one. Plus the cost of equipment of a digital device is low as compared to the analog one. The third advantage it offers is function flexibility, which means that we can easily adapt any relay functionality by some mere changes in the hardware and the software. Means I can easily change my relay characteristics from a mho to ohm to quadrilateral and back to ohm with some mere changes in hardware and the software. The fourth advantage it offers is the self-checking functions, which means that by using the proper hardware and the software, we can easily diagnose the fault. Fifth advantage is easy communication, which means a digital relay offers easy interface with the other digital equipments. System integration and digital environment. The system of the digital relay can be easily integrated with other devices. And the last one is the longer life. Means since there is no aging of components here, it's obvious that the devices will have a longer life. Moving on to the block diagram of a digital relay. Digital relay that are used in for protection consist of the following subsystem. First, analog input subsystem, digital input subsystem, digital output subsystem, a processor with name data scratch pad, main memory, historical data file, and power supply unit. The power supply unit provides the necessary power to the whole relay. From the power system, required inputs are applied to the analog input subsystem and digital input subsystem. According to the relay setting, the relay logic provides the output to the digital output subsystem. The historical data file are used to store the previous records of the digital relay. As the desired output of the digital relay is received by the circuit breaker performs the required operation. Here, similarly, another picture depicting the digital relay construction is similar to the one described earlier. Digital protective relay. Now, what is the digital protective relay? A digital protective relay is a microcomputer controlled relay. For the operation of the microcomputer, proper form of signals need to be fed. So the data acquisition system collects the transducer information and converts it into the proper form so that it can be used by the microcomputer, that is in the digital form. CT and PT are basically required for any action of relay which further command circuit breaker. So first the information is amplified and sampled. The amplified signal is filtered by the analog filter. Now with the help of the analog to digital converter, these sample signals are converted into digital forms so that it can be finally fed to the microprocessor. But before these are fed to the microprocessor, these are again followed to the digital filter for digital filtering purpose. Now with the help of some algorithm, some technique or discrete Fourier transform, the feeded signals are compared with the reference or preset signals so that a comparison can be made whether there is occurrence of fault or not, which further commands after the comparison is made, these digital signals are further converted into the analog signals for either alarm or either for the trip signal. The whole digital relay applies analog to digital conversion process to the incoming voltage and converter, which are get together by the CT and PT. The relay analyzes the analog digital converter output, means the output from this is analyzed here in the microprocessor, where basically you have a phasor comparison, means the fed signals amplitude and angles are compared with the preset reference ones so that further command can be fed for alarm or trip. Here is the overview of the whole system going on in the digital relay. Analog input system. This is the basically CT or PT, which will give the signal, whose signal is then fed to the analog filter. This is the input, and after the analog filter, this signal is filtered out. This filtered out signal is then fed to sampling and hold system so as to get the sample signals. So this is our continuous signal which is then converted into the sample signals. The time interval between the two samples is known as the sampling rate. With the help of analog to digital conversion, the sample signals that are the analog signals are converted into the digital signals. But for the digital filtering purpose, we convert the digital digital signals, the non-filter signals, that is the samples, into the digital filtering signals. These samples are used for phasor calculations, where magnitude and angle are calculated of each sample and then compared with the reference one. After this, the protection method which we have applied for, like if we have applied for the distance protection, the algorithm is present, and with the help of the relay logic, a trip or alarm signal is fed to the power system. Now what is a phasor? A phasor can be defined as a complex number which can represent a sinusoidal signal. Basically, a sinusoidal signal has amplitude and angle both. The magnitude of the complex number provides the RMS value of the signal, that is the magnitude of the signal. That is, the angle of the phasor provides the instantaneous position of the angle. Now, as already discussed, phasor estimation involves estimating the instantaneous angle and RMS value of the signal. This discrete voltage and current signals are fed to the phasor estimation algorithm to estimate the phasor parameters. If Vn is the periodic signal having n samples per cycle, the discrete Fourier transform for the corresponding signals can be written in the following equation form, where Vk is the discrete Fourier transform of the Vn signal, whose real and imaginary part are separated. With the help of this real and imaginary part, we can easily calculate the magnitude and the phase angle part. The cosine term or the cosine transform of the faded signal is also represented by the following equation.